Next, we are going to study about dual simplex method. Now, the steps for that is steps 1. Convert LPP into maximization. Since it is maximization, convert all constraints into less than or equal to type. Third one, convert inequalities. If you have greater than or less than, you convert that to equalities by adding slack or surplus variables. And these slack and surplus variables will have zero coefficients in the objective function and will have 1 as coefficients in the constraints. Okay. That is a normal method that we did in any simplex method. Now, what we do again, like simplex method, compute Cj minus Zj for every column. Now there are conditions. First one, if all Cj minus Zj less than 0 and if all ratio or RHS greater than or equal to 0, we have reached optimal solution. Optimum solution has been reached. Okay. Now the second condition, that is, if all Cj minus Zj is less than or equal to 0, everything is less than 0, but at least one ratio or RHS, I am writing ratio or RHS, is negative, go to the next step, that is step 5. Again, the third condition, if any or all Cj minus Zj is greater than or equal to 0, then method fails. The stopping condition should be less than or equal to, along with the R ratios being all positive. Okay, this is all less than or equal to 0 and this is all greater than or equal to 0. If it is anything is negative, you have to do a certain procedure to make this all positive. Now, if Cj minus Zj is all greater than or equal to 0, then the method fails. Now, the sixth step, in the normal simplex method, what we did was finding the leaving variable first. Finding the entering variable. Now, fifth step. In the fifth step, just the opposite of simplex method, first we will find the leaving variable. Find leaving variable. Now, how do you find this? For this, you find the most negative value, negative RHS. We don't say ratio, that's why we are saying RHS. The most negative will be taken as the leaving variable. Now that will form the key row. Ratio, we don't find it on the right side now, we find it down. So that is why we are saying RHS. Now, sixth step, find the entering variable. How do you find? A. If all elements in the key row is greater than or equal to 0, then no feasible solution. Method fails. Okay. Second condition, if at least one element in key row is negative, find Cj minus Zj ratio. You have to find the ratio below. Okay, that's why we said RHS in the previous condition. Now choose smallest ratio, the normal method, smallest ratio. Now this corresponds to key column, corresponding to key column, and then find the pivot element. Find the pivot element. Okay. Now seventh step, make pivot element 1 and other elements in the key column 0, and find the optimum solution like in the normal method that I am not writing again. Okay, so this is the method. I'll just go through again. Dual simplex method. Now the steps is convert the given problem into maximization. Since it is maximization, convert all the constraints to less than or equal to. Now all the constraints should be less than or equal to. Okay, if it is not so, you have to convert it to less than or equal to. Now if there are inequalities, now you convert it to equal to sign by adding slack or surplus variables. Slack or surplus variables. 0 coefficients in the objective function for the slack or surplus variables, and they will have 1 as coefficient in the constraints. Now calculate Cj minus Zj just like in simplex method, but there is a difference here. Now if all Cj less than or equal to 0, that is a normal stopping condition that we have. But along with that, you have to see whether RHS is all greater than or equal to 0. Then we have reached the optimum solution. Now if all Cj is less than 0, but at least one RHS is negative, there is something negative. Okay, then we go to step 5. You have to refine the problem. If any or all Cj minus Zj greater than or equal to 0, then the method fails. Now to find the leaving variable, just the opposite. Instead of finding entering variable first, we find the leaving variable in dual simplex. You find the most negative value in the RHS. That will correspond to the key row. Okay. Now to find the entering variable. Now the entering variable is corresponding to the key row. You will look into the key row. If all the key elements in the key row are greater than or equal to 0, then there is no feasible solution and the method fails. You cannot reach the optimum solution. If at least one element in the key row is negative, then you find Cj minus Zj ratio. You have to find the ratio using the division method. Correspond that row and the Cj minus Zj value will be divided. Now find the smallest ratio, that will be the key column, and then corresponding element in that key row and the key column will be the pivot element. Now make the pivot element 1 and the rest of the elements in the key column 0, and just in the normal method you find the optimum solution. Except that here you will find the leaving variable first and then the entering variable. Now we will do one problem using dual simplex method. Okay, let me write the problem first. Maximize z is equal to minus 2x1 minus 2x2 minus 4x3, subject to 2x1 plus 3x2 plus 5x3 greater than or equal to 2, 3x1 plus x2 plus 7x3 less than or equal to 3, x1 plus 4x2 plus 6x3 less than or equal to 5, x1, x2, x3 greater than or equal to 0. Okay, now we can see that there is one, this is maximization, so everything should be less than or equal to, but here this is greater than. So you multiply the first one into minus 1 to convert it into less than. So you will have, I'll just convert it and then you will get, I'll write it in this side itself. You will get minus 2x1, then minus 3x2 and minus 5x3 less than or equal to minus 2. Okay, the rest will be the same. Now adding, since all this is less, this is less, this is less, you have to add something to the left hand side to make it equal to. So you convert this, maximize. I hope you have write down the problem when you do. Maximize z is equal to minus 2x1 minus 2x2 minus 4x3. Okay, then we'll add up the slack variables as and when we want. Okay, subject to, we'll do the new one, minus 2x1 minus 3x2 minus 5x3. You will add the first slack variable s1 with the value 1, which is equal to minus 2, which is on the right hand side. Okay. Now we go to the second one, 3x1 plus x2 plus 7x3 with the second slack variable, which is equal to 3. Okay. Now the third one, x1 plus 4x2 plus 6x3 plus the third slack variable equal to 5. So you have to add here 0 s1 plus 0 s2 plus 0 s3. We have zeros for the slack variables, and if you are using surplus variables also, but in the constraints you will have 1 for the slack variables. So you have to write x1 comma x2 comma x3 comma s1 comma s2 comma s3 greater than or equal to 0. Okay. Now we will draw the first table. We'll draw the first table to do the method. Okay. x1, x2, x3, s1, s2, s3, keep it like this. Okay. Now we'll write bases, cost of the bases. Then we have x1, x2, x3, s1, s2, s3, and then RHS. We'll write down the first one. Here, this one we'll write. So this is -2, -3, -5. You will have 1, 0, 0, and the RHS is -2. Okay. Then we have the second one. Here you will have the basis S1 with the cost 0 from the objective function. Okay. Now the second one is 3x1. So you have 3, 1, 7. S1 is 0, S2 is 1, S3 is 0. Right hand side is 3. Here this will be S2 with the value 0. Now the third constraint is 1, 4, 6, 1, 0, 0. Sorry, this is 0 and this is 1. Okay. And the value on the right hand side is 5. Here this is S3 with the value 0. Now what you do is, you first find, before that, you have to write the Cj cost here. Cj is, based on the objective function, it is -2, -2, -4. If you look at the objective function, you will get those values, 0, zeros. Okay. Values from the objective function. See, values from the objective function. These are the values. Okay. Now we got the first table. Now we have to write the Cj minus Zj value. What is Zj first? Zj will be all zeros, because this is all zeros, so this will be zeros here. Okay. Next is Cj minus Zj will be -2 minus 0. So you will get -2, -2, -4, 0, 0, 0. So we have the condition there. If all Cj minus Zj less than or equal to 0, we have reached an optimal solution. But we have to look at the right hand side. If this is less than 0 and this is all positive only, you have reached the final solution. But since we have one negative value, we should go to the next table. So if there are more than one negative value, you will choose the largest negative. Since there is only one negative value, you will choose this. This is the, which is it? S1 is the leaving variable. Now this will become the key row. Now you have to find the ratio based on the key row. Again, in the key row, you have to see if all values are positive, the method fails. But since there are at least one negative value, you can find the ratio. Now to find the ratio, you write, instead of writing ratio here, you are going to write ratio here. That is a difference, ratio. Now how will you find the ratio? -2 divided by -2, you will get 1. -3 divided by, okay, this divided by this. You will have -2 divided by -3, this is 2 by 3. 2 by 3, not minus. Okay, 2 by 3. Then you have -4 divided by -5. You will have 4 by 5. This is 0 by 1, 0 by 0, 0 by 0. So you got the ratio. Now in the normal method, you have to find the smallest ratio. Smallest is definitely this one. If you divide, you will get this one. Okay, divide and see. So this will be the x1, x2 will be the entering variable, and now the pivot column row element will be this one. Pivot element is -3. So I'll write down here x2 enters, S1 leaves, and key element or pivot element equal to -3. Okay, now we go to the next table. The next table you have to make this one 1 and these two zeros. So to make this one 1, you have to divide the whole row by -3. Okay, so let us do that one. We'll draw the next table here. Okay. So I'm going to write here B S. Instead of S1, you have X2 which enters. The rest two are the same, S2 and S3. Here the values were 0 in the objective function, but for X2 the value in the objective function was -2. Value of the objective function in the is -2. Okay, so you write that one here, -2. So this is X1, X2, X3, S1, S2, S3. Now you have RHS. Okay, the first row, now Cj is equal to what will be that? -2. From the objective function you have to write -4 and 0, 0, 0. Okay. Now you write the first row. You write it as first row is row 1. Maybe I will write it here only. Row 1 is equal to old row 1 divided by -3. Old row 1. In old row 1, if you check out and see, you will find -2. This will be -2 by -3, that is 2 by 3. Then you have -3 by -3, that is 1. -5 by -3, that is 5 by 3. Then you have 1 by -3, that is -1 by 3. 0 by -3 and 0 by -3. This is -2 by -3. You will have 2 by 3. I hope you can see. There's a slight darkness, but I hope you can see. Okay. Now the second row, we have to make these two elements 0 based on this one. Old row you had 1 there. Old row you had 1 there. So the old row you check out in this table, you had 1 here. You have to make the 0 based on that. So in the new element corresponding to the new table here, it is 1. So you can directly minus row 2 minus row 1. So we will get row 2 minus row 1. So R2 is equal to R2, old R2 minus new R1. So that will be 3 minus 2 by 3. 3 minus 2 by 3, you have 9 minus 2 by 3, that is 7 by 3. So you have here 7 by 3. 7 by 3. And then you have 1 minus 1, that is 0. 7 minus 5 by 3. 7 minus 5 by 3 equal to 21 minus 5 by 3. How much is this? That is 16 by 3. 16 by 3. Then next value 0 minus of 0 minus of minus 1 by 3, that is equal to 1 by 3. So I'll write here 1 by 3. Then you have corresponding to S2 in the old column, it is 1. 1 minus 0 is 1. 0 minus 0 is 0. And then 3 minus 2 by 3. It is equal to 9 minus 2 by 3 equal to 7 by 3. So this is 7 by 3. So you got the second row. Now to find the third row, in the third row you had the element, third row you had the element 4 corresponding to the key column. So you have to make this one 0 based on the new element which is 1 in this new table. So you multiply by 4. The new row you have to multiply by 4. Let's see. So row 3 is equal to old, this is old, okay, old row 3 minus new row 1 into 4. Okay, so I'll do that one itself. 4 minus 1 into 4. This is 0. Now in the S3 it was 1. This was 1 value. So 1 minus 4 into 2 by 3. 1 minus 2 by 3 into 4, which is equal to 1 minus 8 by 3, which is equal to 3 minus 5 by 8 by 3, which is equal to minus 5 by 3. Okay. So you get here minus 5 by 3. Now corresponding to this, the old one was 6. So it will be 6 minus 5 by 3 into 4. 5 by 3 into 4, which is equal to 6 minus 20 by 3, which is equal to 18 minus 20 by 3, which is equal to minus 2 by 3. So this is minus 2 by 3. Okay. Next we have S1 value was 0 and here it is minus 1 by 3. So it is minus 1 by 3, that will become 4 by 3. Just check out and see. Then S2 value was again 0, 0 minus 0, 0. S3 was 1, 1 minus whatever it will give 1. Then you have 5 in this RHS value. So it will be 5 minus 2 by 3 into 4. So that is 5 minus 8 by 3. 15 minus, did I get something wrong here? The old value is 5. 5 minus 2 by 3 into 4 into 4. So this is 5 minus 8 by 3. 15 minus 8 by 3. 7 by 3. That's right. So you get here 7 by 3. Now to find already we can see all this is positive. Now we just check whether Cj is all less than or equal to 0. So J is equal to, you have to multiply, this will be zeros. This is minus 4 by 3. Now this is again minus 2 by 3. This is, these values will be okay, minus 10 by 3. This is what? 2 by 3. 0 and 0. Okay. Now Cj minus Zj is equal to, what is this? Minus 2 minus 4 by 3. That will be minus 6 plus 4 by 3 is equal to minus 2 by 3. So this is minus 2 by 3. Next we have minus 2 minus of minus 2 by 3. So this is minus 2 minus of minus 2 by 3, which is equal to minus 2 plus 2 by 3, which is minus 6, plus 2 by 3, which is minus 4 by 3. This is minus 4 by 3. Just check out whether I'm doing it right. Okay. I got it wrong here. This one was, it should not be minus 2 by 3. It is minus 2 to 1. So this is just 2. Okay, minus 2 into 1 is minus 2. Minus 2 minus minus 2 is 0. This is 0. Now next is, you have here minus 4 minus of minus 10 by 3. That is minus 4 minus of minus 10 by 3, which is minus 4 plus 10 by 3, which is equal to minus 12 by plus 10 by 3, which is minus 2 by 3. So this is minus 2 by 3. And this is what 0 of minus 2 by 3 is minus 2 by 3 again. These two are zeros. So you can see that all Cj minus Zj is now less than or equal to 0. So I can write all Cj minus Zj less than or equal to 0. Less than or equal to 0, and all RHS greater than or equal to, all positive. RHS all positive. Hence, we reached an optimum solution. Optimal solution. And what is the value? You don't have x1 and x2 in the basis. So x1 will be 0, x2 will be equal to 2 by 3, x3 will be 0. So the values will be x1 equal to 0, x2 equal to 2 by 3, and x3 equal to 0. Now you have to put this in the maximize function. So in the maximize function we had maximize z is equal to minus 2x1 minus 2x2 minus 4x3. You substitute these values, you will have 0 minus 2 into 2 by 3 minus 0. So you had minus 4 by 3 as a value. The value is 4 by 3. So this is very easy. What you have to do is just listen to this video again, and now try doing one problem. I'll write the problem here, and then I want you to give me the answer for that. Okay, I'll write the problem now. You have to solve this problem. Use dual simplex method to solve the LPP given below. So minimum Z is equal to 3W1 plus 4W2 subject to 3W1 plus 4W2 greater than or equal to 24, 2w1 plus w2 greater than or equal to 10, 5w1 plus 3w2 greater than or equal to 29, w1 comma w2 greater than or equal to 0. Okay, so this is the problem that you have to solve. I'll tell you one thing, since this is minimization, you have to convert this into maximization. To convert that, you multiply by minus 1. So it will be maximize z is equal to minus 3w1 minus 4w2. Now since it is maximization, everything should be less than or equal to constraint. So again you multiply all the three constraints with minus 1 and then solve it. Now I will create a Google Classroom. You have to paste the answers for that.